Welcome back to Circuit Meter Insights, the podcast where energy meets intelligence. Discovering how smart analytics, real-time data, and cutting-edge efficiency solutions are driving the future of sustainability forward. So, plug in, power up, and let's dive in.
Welcome to the Deep Dive. Today, we're really tearing up the old playbook on energy management.
Yeah, we are.
We're moving way past just getting that monthly utility bill. You know, the one that lands with a thud and just says expensive.
Right.
We're diving into something called forensic energy management.
It's a critical shift, really. The way most facilities handle energy now, well, it's based on a huge lack of information.
A blind spot.
Exactly. If you're running a commercial building or an industrial plant, you're basically flying blind on where your energy is actually going minute by minute.
Okay, let's start right there. That fundamental problem. What's hiding in that big number on the bill? If I spent, say, $100,000 on power, why isn't that enough information?
Because those utility bills, they're just accounting tools. They look backward.
Reactive.
Completely reactive. And they totally hide operational waste. They tell you what you spent, sure, but never really why.
So they wouldn't show you something like, oh, the heating fighting the AC in the same zone. Or maybe fans running all night when they shouldn't be.
Precisely. Those kinds of simple, constant problems. A bad control setting, maybe. And that inefficiency can just bleed money for months, maybe even years, completely unseen.
Like a slow leak you just don't know about. Undetected.
Yeah, it's invisible in that big summary number. And the old way to try and find this stuff, the periodic energy audit, it has its own problems.
Right, the big audit. Expensive, takes time.
And it only looks at a fraction of the equipment, usually. Plus, it's just a snapshot, a moment in time. It won't catch failures that happen next week or that gradual decline in performance, that drift we talk about.
Okay, so the mission is clear, but sounds tough. We need to make energy visible. Every single kilowatt hour needs to be accounted for, manageable. And the solution we've been looking into, from Circuit Meter, seems to promise exactly that. A transformation.
It does. Circuit Meter aims to provide that really granular real-time data, the kind you need to move from just guessing based on old bills to, well, proactive, precise operations.
Driving actual cost savings you can see improve.
Continuous savings, yeah, that's the goal.
So today, let's unpack that. What is this granular data? Why is it so important for the bottom line? And how does Circuit Meter use it to really change how facilities are run?
All right, let's look at the system itself. Circuit Meter's got the WebMeter 48 hardware and the circuit monitoring a cloud platform. The sources really stress two things: the cost and the level of detail, the granularity. Let's talk cost first. Metering every single circuit used to be, well, crazy expensive, right?
Absolutely prohibitive. That's the paradigm shift Circuit Meter brings. They've engineered the system so the cost is just a small fraction of older metering systems.
So that makes it actually feasible to put a meter on every breaker, across a whole building or even multiple buildings.
For the first time, yes. It makes that circuit-level monitoring economically viable across an entire portfolio.
And that low cost lets you get down to the real nitty-gritty. Monitoring the power for one specific fan, or maybe a single server rack, or one piece of machinery on a production line. That's it, exactly. The WebMeter 48 unit itself is built for this density. It can handle up to 48 inputs, current transformers, pulse data in one box. So suddenly, energy isn't one big bill, it's hundreds of distinct cost points you can manage.
Okay, but hold on. You mentioned data volume. The specs say information goes to the cloud every 2 seconds. That sounds like a tsunami of data.
Yeah.
How do you avoid just drowning managers in noise?
That's where the forensic part of forensic energy management really comes into play. The system isn't just measuring total consumption like kilowatt hours.
It's measuring specific things.
Very specific metrics, up to 334 data points every 2 seconds. But for this kind of forensic analysis, 3 are really foundational: real power, power factor, and maybe the most critical one, operating time on.
Okay, break those down. Why those 3? Real power, power factor, and time on. How do they impact the bottom line?
Well, real power tells you the actual useful work the equipment is doing. Power factor, though, tells you how efficiently it's using that power.
So a struggling machine might have a low power factor.
Exactly. It draws power less cleanly, you could say. And that struggle, reflected in a lower power factor, is often the very first warning sign of a mechanical problem brewing, or just general inefficiency setting in.
And time on. That seems obvious, but you said it's a game changer, especially for controls.
It really is. Before this kind of circuit-level, real-time view, managers were often just guessing how long equipment actually ran. You think your fan runs 8 hours a day because that's the schedule.
The data might show something different.
Right. The circuit meter data might show it ran 24 hours straight yesterday. Instantly, you know you've got a control error, maybe an override left on, or just a human mistake. Knowing the actual operating time, minute by minute, that's the deep dive insight. It lets you manage assets based on actual use, not just assumptions or total energy figures.
Okay, let's shift this to the facility manager's perspective. Their world is about uptime, avoiding those middle-of-the-night emergency calls. How does this circuit meter system help them manage maintenance better, more strategically?
Think of it as a continuous energy audit, but one that's always on, always watching. It goes beyond just tracking energy use. It provides real operational intelligence.
For precision maintenance, you said.
Yes, enabling precision maintenance. And a huge part of that is setting benchmarks and stopping that building performance drift.
Define drift for us again. You called it a silent killer.
It is. Drift is that slow, almost invisible decline in efficiency. Take a piece of equipment, maybe costs $50,000 new. When it's brand new, it draws, say, 10 amps.
Okay.
6 months down the line, maybe some bearings are wearing slightly a little extra friction. Now it's drawing 11 amps to do the same job. That 10% extra energy use, it's totally lost in a monthly utility bill.
But circuit meter would see it.
Instantly, because you can set performance benchmarks for every single circuit. If that motor starts drawing power above its normal threshold, boom, a real-time notification goes out.
Let's use that motor example from the source material. A big HVAC motor, bearings start to wear. Still runs, but it's working harder, fighting itself.
Perfect example. That internal wear and tear forces the motor to pull more current, measurably more, for the same output. The facility manager doesn't see it on the bill, but they get an alert from circuit monitoring. HVAC Unit 3, Motor A, drawing 15% over baseline. Specific. Actionable.
So they're not waiting for the motor to just seize up, causing a huge shutdown, probably on the hottest day of the year.
Exactly. No catastrophic failure. Instead, they can plan for just-in-time maintenance. Meaning you replace those wearing bearings when they become inefficient, not waiting until they fail completely. The cost difference is huge. Proactive replacement is scheduled, it's cheaper, it avoids downtime.
Versus that 3 a.m. emergency call-out, plus lost production, 10 times the cost, easily.
Easily. And it also stops you from doing unnecessary work, right? Over-maintenance. Replacing parts just because the calendar says so, even if they're fine. This is truly data-driven asset management.
Okay, we've kept the motors running efficiently for the facility manager. But, it always circles back to the budget. The financial controller, the CFO. What do they see in this data? Their big headache is often those peak demand charges.
Ah, peak demand. That's the hidden time bomb in the monthly bill, isn't it?
Explain that quickly.
Sure. A facility might hit its absolute highest energy usage spike for just one 15-minute period in the whole month. But that single spike can set a high rate, a high charge, that applies for potentially the next year. It drives costs way up.
And traditional meters don't tell you who set off the bomb.
Not a clue. It's just a peak on a graph. But with circuit meter, because you have that 2-second granularity,
you can see exactly what turned off.
Exactly. The finance team can pinpoint the makeup of peak demand, down to the specific machine, the specific system, the exact time it kicked in. Maybe it was a big compressor starting or several machines firing up unexpectedly at the same time.
And knowing that lets them, change schedules, stagger startups.
Precisely. They can implement very targeted operational changes to target reductions in that peak. It becomes surgical cost-cutting, saving potentially huge amounts on those demand charges.
Okay, beyond peak charges, what about just plain waste? Stuff running when it shouldn't be? People maybe not being as careful as they could be?
Yeah, the human element and just poor scheduling. This is where giving people the right numbers makes a difference. You can use the circuit meter data to break down energy use, maybe by floor section in an office or by shift on a production line.
Ah, so you can show Team A their usage versus Team B.
Exactly. Feed that detailed usage information right back into behavioral conservation programs. When people see their numbers, their impact, it drives accountability.
What gets measured gets managed. Makes sense. Becomes a performance goal, changes the culture.
And there's one more huge financial piece. Validating CapEx, capital expenditures.
Those big investments, new chillers, LED lighting retrofits, more efficient production machines.
Right. Proving the ROI, the return on investment, after you've spent the money is often really hard. The savings get washed out in the total facility bill. Did that new chiller really save 20%, like the manufacturer claimed? Hard to tell.
But with circuit meter, you have the before picture and the after picture right on that specific circuit.
Exactly. You have the historical baseline data for that chiller circuit, and you have the live post-installation data. The system provides the analytics to validate saving investment decisions. You can prove definitively whether that new equipment delivered the promised savings.
That's huge for justifying future investments, too.
Absolutely. And one more thing on the financial reporting side, the platform can convert that real-time energy data into CO2e, carbon dioxide equivalent.
For sustainability reporting.
Yes, quantifying greenhouse gases. Essential for ESG reporting, for reduction targets, for corporate responsibility.
This depth of data, processing streams every 2 seconds from potentially thousands of circuits. It definitely screams big data. How does the circuit monitoring cloud platform actually handle that scale, especially for companies with facilities all over the place?
Yeah, the architecture is built for it. It's designed for horizontal scalability. It handles multi-site, even multi-country portfolios without skipping a beat.
And the information display, how does that work for different roles?
It's hierarchical, which is key for big organizations. Your facility manager might be looking at individual circuit data. The regional VP, they might see summarized performance for all the sites in their region. And the CFO, back at headquarters, they can get a view of the entire company's energy performance, the carbon footprint, all the way down to, that one specific pump at a remote facility if they need to.
Okay, that's a lot of sensitive operational data flying around. We have to talk security. Sending potentially gigabytes of data to the cloud daily, how is it protected?
Security is obviously top of mind. It's designed to work within corporate security structures. All communication uses full AES 256 encryption. There's SHA 256 hashed authentication.
And how does it talk through firewalls? That's often a sticking point.
Crucially, the circuit meter system initiates communication outbound from behind the corporate firewall. It doesn't require any inbound ports to be opened up.
So it pushes data out. It doesn't wait for requests to come in.
Right. That unidirectional flow maintains a high level of network security while still allowing secure remote access to the data via the cloud service.
What if a company already has a sophisticated building management system or an energy dashboard they like? Does Circuit Meter just create another data silo?
No, definitely not. Integration is built in. The circuit monitoring system offers a secured API, usually using standard JSON format.
So other systems can pull the data.
Exactly. It allows for system-to-system connection. That granular 2-second data can be fed into existing control platforms, existing analytics software, any reporting system they already depend on. It enriches those systems.
And we've mostly talked electricity, but utilities are broader than that. Can the system handle other things, like water or gas?
Yes, it's designed for that comprehensive view.
Okay.
While the core is electrical, using auxiliary modules like the J-Pulse 4 counter,
J-Pulse 4, okay.
the system can integrate readings from third-party meters, water meters, gas meters, steam, BTU meters. It all feeds into the same circuit monitoring platform.
Giving management that single pane of glass for all utility costs.
That's the idea, a unified foundation for energy and utility management.
So we've really mapped out a significant shift here, moving from just reacting to a bill once a month, essentially guessing in the dark, to this proactive, detailed, circuit-level insight that Circuit Meter provides.
Yeah, it's a genuine transformation. And it delivers those tangible benefits we talked about. Real financial savings by hitting peak demand, proving ROI on big investments.
And better operations, too, through that just-in-time predictive maintenance.
Exactly. It boils down to that core idea. Meter all circuits in real time. Understand energy use. Reduce costs. That's the heart of forensic energy management.
Which brings us to our final thought. The sources mention something called the Energy Window TV mode. This lets companies display key energy metrics, conservation goals, publicly, maybe in the lobby or somewhere prominent.
Right, making it visible.
Transparency drives accountability, right?
Wow.
So what happens? What's the bigger impact? When saving energy moves from being just a private operational task for facility managers to becoming a public corporate responsibility, something every employee, every visitor, every stakeholder sees when they walk in the door.
That's a powerful question. That public display, it changes the whole dynamic. When energy use is transparent, measurable right down to the circuit, conservation stops being just a technical issue, becomes a shared goal, part of the company culture, a collective mandate. That visibility, I think, that's the real catalyst for deep, lasting change.
Definitely something to think about, especially next time you look at that opaque utility bill and wonder what's really hiding inside. Thanks for joining us for the deep dive.
And that's it for this episode of Circuit Meter Insights. We hope this discussion has powered up your understanding of how smart analytics, real-time data, and cutting-edge efficiency are transforming the energy landscape and driving the future of sustainability forward.